Fire in the hole. Hello and welcome to Fro-Dog Arcade Repair. Today we have a Promax C1000 that is supposed to be a direct replacement / upgrade for a 19-inch G07. This particular unit is used. It doesn't look like it's got a lot of hours, if very many at all. I don't see much discoloration or anything going on the board. Just a quick visual inspection. I see some bent over components. Nothing serious. Nothing looks cracked. I did take the remote board off, just kind of get it out of the way for the moment on this initial visual inspection. I'm going to go ahead and remove it from the plastic bottom frame. We'll take a good look at the bottom of the board, and after this visual inspection, I think one of our early tasks is going to be to wash this chassis. I do like clean chassis to work on. Come on, you little booger. It's caught in the edge of that heat sink. There it is. And I still almost dropped it on the floor. All right. Let's get a couple more screws out here. This is going to start a little G07 run. We're going to look at some genuine G07s. We're going to look at some G07 replacements like this Promax C1000. And like most of my owned boards, I tend to get them off of eBay or various sources in an unknown, untested capacity. We just kind of get potluck, don't know what we're looking at or getting. Checking the bottom side of the board. I do not see anything burnt. I don't see I don't see any discoloration from heat. As with most of the Chinese chassis, it could use some reflow. I don't see anything really ringed or egregious. No, I don't see anything going on the bottom of this board. It looks like a virgin board in that I don't think this has ever been touched, flowed, capped, or anything. I think it was likely a replacement board that didn't see much action. Been sitting on a shelf for a while. It's kind of dirty. Let's do a couple of quick checks here. Let's start over in power. Let's just check the fuses. That's always a good spot. Always start in power, right? Got two good fuses. They look visually good. Does it say on the board what that's supposed to be a 6 amp and a 2 amp. So what is this one? Kind of gotten a little distrustful on where the fuses will be, right? That is a 6 amp. So when you get these unknown boards, you have no idea who tried to repair them before, what their idea of a repair was. And that one is a 3 amp. The board says 2. So let's think about that one. But they are good, not blown. While we're here, why don't we check a couple of the power sandblock resistors, see what those look like. 2.2 ohms, and it's supposed to be 2 ohms in circuit. That seems pretty reasonable. This one is a 220 ohm, 20 watt. We read 213, 140, or no, not 140. 10 watt, 4 ohm. What's this one read? Yeah, 4 ohm. That's pretty reasonable. We've got a couple of 6.8Ks stood off the board. Now, on these Sanwa slash, not Sanwa, got Sanwa on the brain after finishing those. Wei-Ya, W-E-I-Y-A. Wei-Ya and Wei-Ya clone Chinese chassis. Isn't that amazing? You've got a Wei-Ya chassis that's a Chinese chassis that's a copy of various other things in the world, and or at least circuit design that dates back to the early monitors where it's non-switching power supply, diode rectified, and voltage regulated with a transistor. That there would be copies of the Chinese clones. But anyhow, I digress. Keep checking large power resistors here. 6.7K on a 6.8. 5K and climbing, probably through a cap. What I was going to say is this R315 here, this leg closest to our B plus adjustment is where we adjust just that, B plus. So I think when it comes time to light it up, fire in a hole, we'll double check our B plus, of course. I'm going to say age and the fact that they're Chinese caps to begin with. We're going to do a cap kit on this once we prove out some functionality. Tested our big sand block staring at us. Let's go over to diode check. Let's look at the horizontal output transistor over here and our voltage regulator over here. What is our HOT in this one? A C5250. And what is our regulator? A D1402. All right. I think collector is going to be in the center. There we go. Got a junction, not shorted. What have we got right here? Ah, there has been somebody here. We have a fine crack in the board right there, and we have two little solder bridges taking care of that crack. We'll ohm that out here in a moment. One junction. I suppose I could put this meter over where you can see what I'm seeing. There we go. One junction, 506. It is reading short, base to emitter, but in circuit that may not be wrong. Let's just lift one leg. There we go. Go continuity. Pad is. Pin still reads continuity. Oh, coming back over through this, I bet. All right, let's go back to diode with that leg lifted. Let's see what we get. There's our junction. Is that reading shorted? Or darn close? All right, that got me really interested. Let's go ahead and take this HOT completely out of circuit. Yeah, that'll also get us ready for a light bulb test as well. Okay. Back to continuity. Are we touching a pad? Okay. We seem to be... There we go. Now we're no longer touching a pad. All right, completely out of circuit. What does our HOT tell us now? There's one junction. And that is a pretty low drop across there. That looks like a shorted HOT, don't it? 37.5 ohms. I would say that's probably not good. Not good to have happening. There's the little bugger. What did we say it was? 5250 or 5258? You know. $52.50. 2SC 50 250. Let's write that down. We might want to know that. 2SC 5250. So it looks like we've got a shorted HOT. It is a plastic case, so there's no insulator to worry about at this juncture. Just depends on what we replace it with. Anything else going on? Why hadn't our fuse blown if we've got a bad HOT? Maybe that's why that 3 amps in there, and somebody just popped it in to see it happen. All right. Well, next order of business is I am going to clean the white goo off from where our HOT goes. Then I'm going to do an overall chassis clean. We're going to visit the wash tub, the air compressor, and the fan. We're going to wash this chassis and dry it out, and also search out what we have in stock, if anything, for a C5250. All right, we're back over at the bench with our Promax G07 replacement, and something that I figured out that was just not sitting right with me on the HOT, and I know now why it reads the way that it does. These Wei-Ya and Wei-Ya clones tend to use HOTs that have the built-in damper diode and resistor. And what I'm reading when I look at it on a meter between the base and emitter is that damper diode and resistor internally in the unit. It is not a dead flat 0 ohm short kind of thing. So I think the HOT is fine. What I do have is I pulled the flyback cage off. I pulled the flyback out to get down to working on the board. And that little bit of a crack that we have, I think might be some shipping damage at some juncture. See if I can get it in frame or in focus well enough for you to see it with me. Can you see the crack right here? And that extends on across over into about here. So we've got three broken traces, and it's all from the weight of that flyback and where it screws on to the heat sink. I think this took a bump in shipping, and that's what cracked the board. Now, on the SanWas that I had a cracked board on, the board substrate wasn't just this plastic. It was more like a woven, almost like a fiberglass layered woven kind of scenario. And when I laid super thin CA on it and soaked it down into that crack and kind of formed the board with a little heat into the shape that it belonged in, it stiffened right up and made a nice solid basis for our repair, and everything looked great and felt great. Now on this plastic substrate stuff, it is not quite the same animal. So I've been thinking about how to do this, and I was at Hobby Lobby and I picked up some mosaic mesh tape. I believe this is for mosaic tile laying. And what it is slightly sticky on this side, and it is like a fibered mesh product. It's just in a roll. So I laid 2 layers on the board and offset them so that they evenly spaced to tighten the grid by double. I also laid another little double piece of it over here so that my whole flyback area after our repair would be at the same height. Make sure that's good and flat. Now what my plan is to use that CA product where it has the little powdery stuff, and I'm going to lay it on and kind of screed it with the edge of a card down into this weave pattern. It's almost like a gauze weave, just or like even a chicken wire weave, but it's, you know, it's nice and small, and then 2 layers offset from each other. Cut the whole size down by 25% as well. So the CA should stick to the board decent. This should give it some substrate to hold on to and to make a stronger, almost like a plywood type repair. And I'm intentionally doing it on the component side of the board because I'll probably have to run a drill bit through for making sure that the leg holes are open for the flyback. But when it's all said and done, the flyback is going to sit back over top of this, and the cage is going to be around it, and cosmetically, it's going to disappear. We're not going to have near the cosmetic concerns, as well as on the bottom where we bridge those traces, we'll put some of the green conformal coating on. So, without much further ado, you know, I am going to put some rubber gloves on just to make sure I don't super glue myself to the project. Okay, now going to this level for the repair is probably overkill. A lot of people say, oh, Chinese chassis, it's definitely overkill. But if I just did a little CA on the crack, bridge the solder on the bottom, more than likely it would be fine, especially if I would just go put it in service in a cabinet somewhat right away and didn't ship it anywhere. But shipping and or moving this around, the weight of that flyback and stressing and moving that heat sink that's back here is gonna just exacerbate and aggravate that spot on the board. So I've been kind of wanting to try this with a mesh tape or a mesh type product. I originally thought like surgical gauze, like bandage gauze for injuries, but we're gonna see how this works out. I do want to get a piece of packing tape here and put it on the bottom to make sure we don't have a lot of spill through of our powder product through those flyback holes. So actually it might take 2 pieces. Yeah, we'll put 2 pieces. But this is just to keep our CA and various product from falling through and sticking to my silicone service mat. Even though it's silicone, it may not stick. I just don't want an extra mess to fight or clean up. So we'll do that. And then we'll try some of our powder and kind of screed at it with our card here and go through and see what happens. Now on this side, our crack is right here in that weak spot of the board between those two open holes. And if I am correct, the flyback doesn't even need those holes. So filling those in with some CA and this granular product ought to help that a little bit further. So, like I said, this is probably overkill. But by gosh, we ought to have a solid repair when we're done. Like I said, we'll probably have to re-drill some holes. The only reason for putting the product back in this area is to make sure that our finished product is level and that the flyback's going to sit at the same height or position all the way around. I definitely am seeing our holes for our flyback legs filling in, so we'll be doing some re-drilling, I'm sure. Alright, we got that pretty well coated. Now, pretend we're a concrete guy here. Tidy this up and screed that off a little bit. Ooh, that's a lot of product. I don't want to waste that. Let's put this tablet under. We'll screed off our excess onto my tablet here. And try to put it back in the container. Waste not, want not, right? I don't want a whole bunch of extra product all granular everywhere on the board. So let's try to clean this up best we can. Get all of our excess out of the way, or at least back up into the work area. Yeah, somebody's sighting in a rifle or doing something. I hear gunshots in the background, but since we're not inner city, we're out here in the country, in good old Park County, Ohio. That is not an uncommon phenomenon. I've been known to be the one making that noise myself. Just country boys and girls getting down on the farm. All right, let's see what happens. For all of my naysayers out there, it's just a Chinese chassis, it don't matter. Another one of my board repairs. I actually kind of like that technique. I think it worked pretty good. Doesn't look too bad. We'll see what we need to do to drill out some holes, because we definitely filled some in. Boy, this packing tape sticks a little different, a little worse than the old Scotch tape. I'm actually trying to be careful. I don't want to pull a trace off the board. Okay. Now it does look like perhaps we need a little more CA down in those divots that we filled in. As it didn't soak all the way down there. Alright, maybe we'll just try to, instead of the full-on drip from the bottle, let's get a long stem swab here and maybe just drip a little. If I don't end up spilling the whole darn shooting match, that would be bad. There we go, selective. Selective dribble. Okay, I like that. Blot that, make sure we don't have any erroneous extra creeping around CA on us. Now, where is our fiberglass pen? That little bugger's here somewhere. All right. Yeah, that packing tape left a little bit of residue behind. Nothing a little denatured alcohol can't cure up. All right. Oh yeah, that's stiff. That definitely took and added some strength to that area. I do not believe we're going to have a future crack problem there. Crack's bad, kids. Stay off drugs. All right. We are just going to drill these holes. You know what? I'm going to get a block of wood to go under there. Just so I don't start punching down into my mat. That would be bad. Plus it'll give me something really good and stable to push against. A little bit of speed makes it go through faster. Let's test fit our flyback here. Make sure we have all of our holes. Alright, as with most flybacks and or repairs, this looks like it's going to be a little more tedious. Oh, there we go. We got some popping in. Oh, there it is. Okay, our flyback sits back in there. Now, what about, that goes this way, our heat sink slash flyback cage. Line our legs up for our regulator and our HOT. Turn it up on the end. We'll do the hokey pokey. No, that's not the same sport here, sorry. There it is. Got it started. Get our heat sink and our flyback cage all back into position. We'll get our flyback screwed down to it at whatever new or altered height we may have from our board repair, and that'll determine how far our legs stick through. And then we'll solder everything back together. Oh, that wire harness is under the edge. That's why it's having a hard time down there. Alright, that's better. Okay, so now we have that part done. Now we've got to get our flyback screw all lined up here. It's got this little extra collar with it. Okay. Righty-tighty, lefty-loosey. Is that moving around much? No, it's at the depth it's going to set. All right. So let's solder our flyback back in. I think I'm going to put the soldering iron away for the moment only. Yeah, that's a sand block resistor. We should probably hit that too, because we're going to need a soldering iron to do our cap kit. Before I dig into a cap kit on this, you know, it just looks so brand new, but it is a little aged. I'll probably do a cap kit on it. Let's do one other thing here. Let's pull this B+ filter cap out and give it a little test out of circuit and see what it's all about. Oh, and we still got to fix those cracked traces. We've got to solder some bridges across there. Yeah, it's just not quite Chemwick now, is it? The old Towot wick. T-O-W-O-T. It's like $15 for a roll that size, where the Chemtronics Chemwick is like $50-$60 for a roll that size. So Call me parsimonious. Let's see, can we prop that up so we both can see it without a glare? There we go. Clip some leads on this, see what it says. 477 mic at 0.12 ESR, and it is a 470 mic 200 volt capacitor. So I believe our B plus capacitor is just fine and dandy. Dandy, I tell you. Fine. Now I say that's a fine capacitor. Again, before we get all froggy with a cap kit, I say we put this back in its plastic frame, get our remote board plugged back into it, and we'll take it over to a G07 tube and yoke setup and light it up. One more little step I often neglect to show, but should be done when you wash a chassis, is I use Deoxit D5 as a contact cleaner and protectant. It cleans, protects, lubricates, and all the pots should get a little shot of that and get wiped, because we're going to set most of them to center anyhow. And to get just that little bit of spray, the Deoxit, if you look, has a low, medium, high twist right up here on the top. I turn it over to low, and every pot gets a little shot. Let's get these ones on the board as well. Okay, we got our ones on our neck board. Actually should come in from the bottom. That's where we're going to get the most into the pot. Now, because this does not just clean, it lubricates, this will indeed leave a residue behind. We're going to give our B plus pot a little shot of it here. We'll adjust the B plus, but we're going to look at where it's at right now. We're going to wipe the pot back and forth, and then we'll put it about where it's at. So if we look, our pot is sitting just about here, centered on this corner notch. So and we'll return it to about where it was, so that should be pretty good to go. I like to also look at where the pots are when I start. See if they're egregiously pushed to one side or the other to perhaps indicate somebody else's problem or work with it. Just because I'm anal retentive about it. I'm going to go ahead and clean this neck board real quick. So, how many of you were sitting at home going, guess what the big dummy forgot? He forgot to repair his traces that were cracked. We went through all that motion to fix the board and mechanically restabilize it. And what did we not do? Repair the traces. So I got it all put together, took it over to the tube, got everything just ready to hook up, and I'm like, something wrong, something I'm forgetting. All right, before we get too far away, I don't know if this part will hit the cutting room floor or not, but did anybody else remember that we had a 3 amp fuse back here instead of a 2? Now it's got a 2. We've got our test pattern on the screen. Now I am using the Crafty Mac test pattern generator, and our connections here are for a red, green, blue ground and composite sync, which is on our negative horizontal sync, which is what these boards like and what the original G07 liked. This particular chassis also has the Let's see if I can... There we go. My fingers are in frame now. We have our yoke connect, or not yoke, our degauss connectors plugged in right there because this has degauss. Has a nice little degauss button right here on the remote board. And we go through a degauss cycle. Nice and easy. Remote board has all of our goodie adjustments on it. This particular chassis is dialed in and tuned up for G07. And a couple things that I like to do on these specifically is I'll mark the red, green, and blue drives down on the main PCB chassis, and then I also mark the red, green, blue up here on the cutoffs on the neck board. Thank you for joining me at Fro-Dog Arcade Repair. I hope you enjoyed the video, found it useful, or at least entertaining. Please subscribe below, like, follow, and share with your friends, and remember, fire in the hole.